Good morning, Hamilton County 4th graders. It is Wednesday. It is hump day. We are working in day 3 of week 5. Since we still don't have protractors, we're still going to be going through these lessons using our benchmark angles, our 90-degree angles, and our 180-degree angles. So today we're going to go over our instructional book, page 312 through 313, our practice book, 317 through 318, and our day 14 countdown. Let's get right into it. We have the instructional book, page 312. This is guided practice, so hopefully you guys have tried this on your own before resorting to the video, because we have been doing this for the last 4 days now. If not, and you feel like you need a little bit extra help, follow along with me, that's fine. Looking at the example, it is, what is the measure of an angle at the top of the roof in the drawing to the right? So we have a couple different angles in this picture, but they're wanting us to look at the angle at the top of the roof, right here. So this would be our vertex. And if we had a protractor, what we would do in order to make this easier to read, we would flip our protractor around. That way that vertex is right in the center. And we have one ray going straight to the 0 degrees or the 180 degrees. And then the other ray is pointing to our angle measurement, which is about 123 degrees. If you can see that, it wouldn't be, see how we have up the top, we have 50 degrees and 60 degrees. It's not going to be the smaller unit, because we can tell that this is an obtuse angle and it's going to be more than 90 degrees. So we're going to use the larger unit of 120 degrees. Sorry about the camera, it's unfocusing. I'm actually in the house and not in the office this morning, and so I don't know, maybe it doesn't like my lighting. Alright, number 17. What is the measure of the angle below? Well, if we turn it this way, that way this is my 180 degree ray, or my 0 degrees, and we draw our benchmark angle of 90 degrees. So this would be our 90 degree ray. And what we notice about this angle is that it is less than 90 degrees and not nearly 180 degrees. Now remember how when we were splitting that 90 degrees up into like a 45 degree angle? That's kind of what this looks like. It looks like it's split exactly down the middle, maybe a few degrees more. So half of 90 would be 45 degrees, and that is really close. That one, I might give it like an extra degree just for giggles. So we'll say 47 degrees. So still using those benchmark angles of 90 degrees and 180 degrees to estimate how wide my angle opens. The next page, it wants us to draw an angle that is 135 degrees. I wish this thing would stop freaking out. Stop it. Thank you. So before I try and draw this angle, I'm going to draw my benchmark angles. I'm going to draw my 90 degree angle. This is my 90 degree angle. And this is going to be my 180 degree angle. So I have my 90 degree and my 180. 135 is going to be more than 90, but it's not quite halfway to 180. So a 135 degree angle is probably going to look more like this. That would be my 135 degree angle. Number 19. Which set of points can be used to draw a 105 degree angle? Circle the correct answer. So we have points on each of these choices. We need to decide which points could be used to draw an angle of 105 degrees. So let's go ahead, let's connect some dots. If I connect this dot, is that a 105 degree angle? No, the measurement looks right, but I know that this angle should be obtuse because it's more than 90 degrees. But the points drew an acute angle. So let's look at this one. So we have a point here, a point here, and a point here. So maybe this way? No. This is all skewy because it's not lined up with our vertex, is it? No. Let's look at D. D looks like it has the same problem. D is not lined up with our vertex. So the angle that we draw is really off and really not right at all. B, there's our vertex right there in the center. We have a ray going out to 180 degrees or 0. And then look at that. That's our 105 degree angle. So we're going to take B. Now Maya chose C as the correct answer. How did she get that answer? She might have mistook that center point down here for the 90 degrees. So it might have been more like that. And so Maya thought our vertex should have been at the 90 degrees instead of the center of the protractor. Protractor, I ran out of room. Let me move this so you can see this. If I'm going too fast, you can always pause the video. Here we go. Moving on to the practice page. I'm kind of flying through this because this is our guided practice, okay guys? When we come back tomorrow for lesson 30, it'll be a little bit longer because we're going to start taking these angles that we're measuring and we're going to start adding and subtracting them. So, page 317 in the practice book. Vincent turned his head 30 degrees to the side. Which of the following shows the angle that he turned his head? So we're looking for an angle that matches 30 degrees. So why can't A be our answer? Well, A is too big. If we think about our benchmark angle at 90 degrees, our ray goes beyond our 90 degree point. So this is going to be an obtuse angle. And obtuse angles are more than 90 degrees, and 30 degrees is not more than 90 degrees. So A is not right. Looking at C, C looks like it already has our benchmark angle drawn. It already looks like this is a 90 degree angle. If this is a 90 degree angle, could it be 30 degrees? No. Let's look at D. D is way more than 90 degrees, isn't it? This is almost 180 degrees. So this is no way, shape, or form going to be our 30 degrees. And then finally we have B. This looks right. This is an acute angle. It's less than 90 degrees. It's less than 180 degrees. I'm going to say B is my 30 degree angle. Number 2 says, which is the measure of the angle that the diagram shows? So we go to our vertex. Is our vertex lined up with the center of my protractor? It is. I have one ray going out at 180 degrees, and my other ray looks like it's going out. Now remember, I'm not going to read these bottom numbers because this is obviously bigger than 90 degrees. So I'm going to look at my bigger numbers. And it looks like it's about 105 degrees. Now Danny chose A as the correct answer. How would he have gotten that answer? Instead of reading, well, if he had gotten A, he got 75 degrees. So I'm thinking he forgot to look at those bigger numbers on the protractor. So he read the numbers less than 90. He read the letters. Not the letters. We're in math. The numbers less than 90 degrees instead of the numbers that were greater. Whoa, I totally went off page on that. There we go. Again, if you need to pause it to write that down, pause it. But I am moving on. Number 3. What is the measure of the angle below? Thinking about those benchmark angles. Here's my 90 degree line. Here's my 180 degree line. Now, looking at where the angle opens, I do not have a wide opening like I would with an obtuse angle. Come on, fix yourself. So if I were reading this on the protractor, I would be on this side of the protractor, but I'd be reading the smaller numbers because this angle is obviously less than 90 degrees. So I'm going to say it looks like it's a little bit more than halfway. So half of 90 degrees would be 45 degrees, which would look about right there. So I'm going to say that this is probably about a 50 degree angle. Now if we're going to draw a 120 degree angle, I could draw my 180 degree line, which it should have been a little bit straighter than that. I think I might have caught a groove in the table. My 90 degree line. So if this is a 90 degree angle, and this is a 180 degree angle, then a 120 degree angle is probably going to look something like this. And I should have done that in a different pen. This is going to be my 120 degree angle. And then finally we have number 5. Nico turned the dial on a combination lock 70 degrees. Then he turned the dial in the same direction another 25 degrees. Measure the largest angle in the diagram below to find out how many degrees Nico turned the dial. Well, if he went 70 degrees and he moved it 25 degrees, now we could use a protractor or we could use our benchmark angles, but this is actually going to preview into what we're going to be doing tomorrow. If I want to know how much more degrees he moved after he had 70 degrees, all I really need to do is add my degrees. Remember, think back to Monday's lesson. We agreed that angles turn at 1 degree. So this angle, the 70 degree angle, is 71 degree turns, and the 25 would be 25 1 degree turns. So if we added our turns, 70 plus 25, we would get 7, 8, 95 degrees. That angle is 95. And we'll get more into that tomorrow. Alrighty. I've got 10 minutes before my meeting starts, so I can finish this up really quick. Our day 14 countdown, the factors of 32. We have 1 times 32. We have 2 times, what would it be? Hang on. 2 times 16. And then 4 times 8. And I want to say that's it. So the factors of 32 are 1, 2, 4, 8, 16, and 32. Number 2. Donald has a coin collection. He has 36 dimes, 72 quarters, and 18 nickels. He wants to arrange them into equal groups with only one type of coin in each group. How many can he put in each group? So, how many does he have all together? If we add 36 plus 72 plus 18. We have 8, 9, 10. That'd be 16. Then 7, 8, 9, 10, 11, 12. We have 126. And if we wanted to put them into equal groups with only one type of coin in each group, we would have 4 groups. Number 3. Write a number between 80 and 100 that has exactly 4 factors, one of which is 5. So remember, our factors of 5 either have to end in 0 or 5. So it would be 80, our choices are 80, 85, 90, 95, and then 100. And now we want a number that has exactly 4 factors. So 80 has 8 times 10, and then 2 times 40. 90 would have 3 times 30, and 9 times 10, and 90 times 1. This would have 80 times 1. 85 would have, there we go. There it is. 85, because we only have 1 times 85. And then it would be 5 times, it'd be once, let me do my mental math, 35 times 70, and then that would be it. So 85. Number 4. Miss Mattingly has a pattern with the initial term of 17. If the rule is multiply by 4 and then add 13, which of the following numbers could be part of this pattern? Explain how you found your answer. Well, if we're multiplying by 4 and then adding 13, we could do the opposite. If we were going to divide by 4 and then subtract 13. So if we can't divide it by 4, it's not going to fit in our pattern. So 4 divided by 337 would be what? That'd be 8, 32, and already I'm seeing a problem, right? 4 can go into 1362, and 4 can go into 80. 4 cannot go into 337. If we do, I would still have 1 left over. So we would say, which of the following numbers could be? So 80 and 1362 can fit the pattern because they are multiples of 4. Jalen wrote the number 23. His rule was add 6. Which of the following numbers would be in Jalen's pattern? So if we added 6 to 23, we would get 6 of 29. So 29 would be a part of it. And then I add 6 to 29, that'd be 9, 10, 11, 12, 13, 14, 15. Carry the 2, that'd be, or carry the 1, 35. 35 would be a part of it. Then we'd add 6 to 35. That would be 11, 3, 4, 41. 41's not going to be a part of it. 41 plus 6 would be 47. And then 47 plus 6 would be, that'd be 13, 53, keep going, because obviously that one and that one's not going to be there, but I'm pretty sure, yep, 59 would totally be there. Alrighty, and that's it. We had a pretty easy day today, huh? Very, very simple. We'll be back tomorrow. It'll be normal, I promise. I had a bunch of stuff sitting on the table in the office, and so I had to come in here and do this, and I would have probably spent a little bit more time going through the countdown. So if you're still stuck on one of the countdown questions that I didn't go all the way through with, just call me or message me and I will work it out with you over the phone. I'm still going to be performing DBAs. I do have 3 actually scheduled today, but it only takes me about 10 minutes, and so I will be continuing to call. I still have quite a few students. I think 32 students still need to take this DBA, so be aware of that. Be reviewing your area perimeter, your converting measurements. I was wondering what that was. Your line plots, your fraction rules. Be sure you're going back and reviewing that before I call. Alrighty, guys. You guys have a great Wednesday, and I hope you guys have an awesome day, and I will see you tomorrow.